If you want to boost your SAT score, you got to practice. If you want to practice as efficiently as possible, you got to be using DESMOS often. That's what we're going to be doing in this series. We're going to go through the entire practice test. We're going to use DESMOS whenever we should be, and we're not going to be using it whenever we shouldn't, because this one is so freaking easy that the problem was already done before you even knew I started it. We are done, and now we're moving on to the next one. John paid a total of $165 for a microscope by making a down payment of $37 plus P monthly payments of $16 each. That means we're doing $37 plus 16 times P. Now, what does that total out to? It totals out to $165, and looks like we got our answer right there. Let's move on. And real quick, y'all, don't forget, you got to go to this website if you want to actually improve your score. Now we're going to continue with the practice test. Well, I don't even have to read what they're saying because I can tell what they're saying by looking at all these answer choices. They're asking me to solve this for M. If I want to get the M on its own, I need to get rid of the 7. How do I get rid of a times 7? I divide by 7. And it looks like we is done. Once again, don't forget that website. That's how you improve. Best thing you could ever do for your SAT score. And I know everybody's going to be screaming, oh, I know how to type this one into DESMOS. Why don't you show us how to type it into DESMOS? Because it's too easy. That's why. Because it's just 24 plus 1, which is 25. Square root of 25 is 5. We're moving on. I'm faster than the DESMOS in that problem. I want y'all to remember that this is only problem 5. That means you need to be able to get these ones done in seconds. So we're just going to look at the actual question. They say, what's the probability of selecting a student whose vote for a new mascot was for a lion? I'm seeing mascot, lion. I'm looking at this row. And I'm looking at the end, the total. That's very common that they ask you probability problems where you're going to take that total number and you're going to divide it out of the grand total, which will often be hiding in this little corner right here, 20 out of the 80 students. For confirmation, you can read this. It said this is for 80 students. 20 out of 80 is 1/4. We are done. We are moving on. That's my favorite website right there. In this one, they are giving us an equation. What do they want us to pop into that equation? Ooh, profit, $900. That's cool. I'll put that right here. And then they say, how many school posters do I have to sell? Well, X is the number of school posters, so basically just solve this for X. Okay, so let's move the minus 220 to the other side. It's plus 220. That's 1120. Now that's equal to 5x, so I just have to divide that by 5. Are we finally using DESMOS? Yeah, why not? Let's do it. Let's do 1120 divided by 5. Okay, first time we actually needed DESMOS. Didn't really need it, but whatever. We're done. We're moving on. Alert, alert, alert. We have a problem that's too easy. This is going to waste your time. Let's see. Y-intercept looks like it's about a positive 10, not a negative 10. Get the hell out of here. Positive 10 y-intercept. All right, slope. This thing is heading down when it goes to the right. That means it's a negative slope. Answer's B. This was a waste of our time. All right, I know you guys are thinking, oh, I see 2 equations. I know I'm supposed to plug that into DESMOS. Nope. Subtract 2 equals 2y, y equals 1, done before you even typed it into DESMOS. Watch out. All right, remember we're still in the early part of the test, so we only got baby problems here. What is the maximum data value in the data set? You just have to realize that they're giving you data values as low as 6, but a frequency of 3. That means that you have 3 6s. 7 frequency of 3, so that means you have 3 of those. And then by the time you finally get to the last one, 14, you would have 6 of those. So what does that mean for us? It just means that the maximum data value, it's still 14. So I'm explaining this with more than 2 seconds. But if you knew what you were doing, the answer for the maximum is 14 within 2 seconds. Time to move on. Here they got 2 circles. They're asking for the total area. They gave you the area of one of them. They only gave you the radius for the other. So what's the formula for the area of a circle? It's pi r squared. So for this one, we plug in the 4. We got pi times 4 squared. That is 16 pi. The other one, we want to add on the 100 pi. 100 plus 16. That's my boy right there. We moving on. Don't forget to hit up your boy. Here we got 4 minus 3x, 4 minus 3x, and they asking us about 4 minus 3x. I put a u over that because I like to think about this as if it was just 9u plus 2 equals 8u plus 18, and now I'm solving for u. How am I doing that? I am subtracting 8u on both sides. That means I will now have u plus 2 equals 18. That means u equals 16. What were they asking about? 4 minus 3x, but I called it u, so that means I already have my answer because this is 4 minus 3x. 4 minus 3x is equal to 16. We done. All right, they're telling us that we got 2 triangles that are similar. Let's make those triangles appear. Then they're telling us that we got G and K that are right angles. So let's say that G is here, K is there. All right, then it's FGH, so we got to put FGH and JKL. And now they're asking what is the value of sine J, but they're giving me sine F. So sine F means we have that the opposite could be 308 and the hypotenuse could be 317. So it could be something like this, 308, 317. Now for J, because it's similar, that must mean that I'm going to have all of these sides multiplied by the same thing in order to get me to the other sides. Now, maybe it's as simple as 10. If it's as simple as 10, then I'd have 317 with an extra 0 at the end of it, and 308 with an extra 0 at the end. And if I were to set up the opposite over hypotenuse for that, you would get 308 with a 0, 317 with a 0, but those zeros would cancel out. So you would get the same thing. So this happens with similar triangles. If you're dealing with equal angles from similar triangles, then your sine or your opposite over hypotenuse will end up being the same for each one. So answer here is B. All right, first thing we got to do here is draw a wire that's 106 across, but it's cut into 2 parts. So here's our cut, and one part is going to be called X, and the other part is Y. And then it goes on to tell us that the value of X is 6 more than 4 times the value of Y. So this is the equation that you get out of translating this sentence. But I know another equation I can write down just based upon how the diagram is drawn. I can say that X plus Y has to equal 106. But I know that 6 plus 4y, that is equal to x. So I can just put 6 plus 4y where I see the x, keep everything else the same. This will allow me to solve for y. So I'll just solve that for y'all. We get y is 20. But remember, y plus x was equal to 106, so that means 20 plus x is equal to 106, so that means x is equal to 86. We got a good problem here that will help us practice our units. They are asking us what is the best interpretation of x in this context. X is right over there. And the way I like to practice my units is to take my equation and think about the units that I have for the number that's on its own. Well, in this case, they're saying that it's total number of trees. So that means that the unit for that is trees. Okay, so what does that mean? That must mean that the unit for 5x must be trees, and this must be also trees. So that we have a certain amount of trees plus a certain amount of trees equals a total amount of trees. Okay, but now I got to figure out what's the unit of just the 5 on its own. Well, they're saying that the 5 is a hectare. Hectare is kind of like an acre. It's just a way that you measure land area. That doesn't really matter too much for our unit analysis, though. I'm just going to call that a hec. But remember, it's going to be hec times the unit for the x, which is going to have to somehow come out to a unit of trees. Well, how is that going to go down? Here's the answer. You're going to need to have trees per hectare, so that way the hectare part cancels out. So that must mean, just with a little bit of analyzing the units, that we're looking for trees per hectare in our answer. So trees per hectare, but is it for the industrial park or for the neighborhood? Well, just a little bit of reading will tell you that the 5 was for the industrial park, not the neighborhood. So we are done with this. So analyze the units. Hectares times trees per hectare must come out to trees, which is what we know it has to come out to by looking at the right side. First thing you got to know is that just like a tree has its roots at the bottom of a fraction exponent can become your root. So we're going to make this equal to the 12th root of a to the 11. Now I'm seeing the 12th root of a to the 132. That's clearly not going to be the answer. But now I can work backwards on some of these other answer choices and make this one 132 over, take that root and put it on the bottom. Could that be the same? Well, you know what? It actually can be, because if you multiply 12 by 12, you get 144. And if you multiply 11 by 12, you get 132. So yeah, that's actually our answer right there. All right, so to conserve our brain cells, we are going to open up DESMOS finally. And they're telling us that g of x is the result of translating the graph of f of x up by 4. Now, what I wrote over here is f of x, but if I want to get g of x, then I'm going to need to put 4 plus whatever f of x was. And now they're asking me what's the value of g of 0, and because I'm using DESMOS, it just calculates for me nice and quick. Even though that's not that hard to do without DESMOS, it was kind of nice to just guarantee that I didn't make a mistake on the multiplication here. So answer is 76. Let's go. All right, looks like the SAT was trying to make your life a little bit difficult here, because when you type in these two equations, they look like they might be parallel, but if you scroll down, you can eventually click to get the intersection. And they're asking about that solution, but they want you to do x minus y. So you click on the thing to pull it in here, and we want to subtract x and y. So I actually want to put a minus sign in between them. Now those parentheses are not really going to matter here. So the answer here is 35. We're done. Oh look, cool website. They're asking about which of the following is the best interpretation of the y-intercept of this. Well, you get a y-intercept whenever x is equal to 0. In this case, instead of having x, we have t. So if you let t equal 0, then 0.65 to 0 would be 1, and you would just get that 8,000. That must mean we're going to go after one of the answer choices that has 8,000 in it. Now, is the 8,000 the minimum estimated number of coupons that they sent during the 5 years? Or is it the estimated number of coupons the company sent to the customers at the end of 1998? Now, if you've been practicing, you will notice that this phrase at the end of 1998, that's describing a certain amount of time. It's describing a specific time, actually, I should say, because it says T represents the number of years since the end of 1998. But wait a second. If T was equal to 0, if we were 0 years since the end of 1998, then when are we? We're at the end of 1998. So yes, that is definitely the one you're going to want to have in your answer choices. That phrase needs to be in there at the end of 1998. Very, very common problem. I like to call these problems the zero numbers, where you're going to be sticking in 0 somewhere, often for time. All right, this problem is a little hard to wrap your head around because of all these variables. So imagine if these variables weren't there. Just pretend that it was saying that we're going to put 88 ounces of water in a bucket in 5 minutes. Well, then how many ounces of water would the hose put in a bucket in 9 minutes? Well, how would you do that? You would just set up a proportion where you say 88 over 5 is equal to some mystery number over 9. Now, it wasn't really 88. It was supposed to be 88x, and it wasn't 5. It was 5y, and over here it wasn't 9. It was 9y. So now the proportion is set up correctly, and nice enough for us, though, is that the y's can actually cancel out on both sides, and all we have to do now to solve for that mystery amount is to get rid of the divide by 9. Well, how do I get rid of a divide by 9? I get rid of it by multiplying by 9. That'll get rid of it, and now you're left with this, and it looks like 9 times 88 is probably 792, and I should be done with the problem right then and there. All right, for this one, I do recommend just going to DESMOS. It is going to take you a little bit of time to solve that by hand, but it's going to take DESMOS very little time. When you get these vertical lines showing up, you want to zoom in and try to see where it's on top of, and clearly it's on top of -3, and we're done. Here they're saying that we have a triangle that's similar to another triangle, so let's start by making a triangle, and then let's make another one that's similar, so same shape. But then it tells us that the measure of angle Z is 20. So let's just pretend that this is X, Y, Z. And then the other one is R, S, T. And then the next fact that they give us here is 2 times XY is equal to RS. So who knows? Maybe this is 10, and then that would make this one 20. 2 times the XY is equal to RS. But that's actually not going to affect the measure of angle T. The measure of angle T is just going to be the same as the measure of angle Z, so we're done. All right, here they're giving us that f of x is equal to 9 times 4 to the x, and then they're talking about f of x plus 2. And they're saying that that's equal to g of x. But then all we got to do is replace the x with x plus 2. Now, do I see that answer here? No, they're not trying to make it too easy, but I can easily use a exponent rule that says that this must be the same thing as 4 to the x times 4 to the 2. Now, what is 4 to the 2? It's 16, and if I then multiply that by the 9 times 16, I don't know, what's that, 90 plus 6 times 9, which is 54, so it's 144 times 4 to the x. That's our answer right there. All right, we got a baby problem to start off the harder section. They're asking for the median, so I go boom, 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 and we done. So I already drew the triangles here. Maybe it's L, M, N, and P, Q, R. They're telling us L, M, N, and P, Q, R are similar. That means all of the matching angles are going to be equal. So when they give you M is 53, that means that Q must also be 53. And that's actually what they're asking about. So super easy problem. We didn't even have to use the fact that it was a right triangle. All right, they're giving us an equation down here. Let's take that equation, and because they're asking for A, we can notice that A is in the table here as the 0.3 comma A. So what that means is you're going to take the Y value and replace it with A, and you're going to take the X value and replace that with a 3. But you're still going to have equals 4 times 2 raised to the 3. And also you're still going to have this plus 3 out there. So now we just have to solve this, and this is super easy because 2 cubed is 8. So 4 times 2, that's 32, plus 3 is 35. So we can try to solve this equation, but if we did that, we're going to end up getting 0 equals 0. And when that happens, it means you have infinitely many solutions. You can also just go back to the original thing and think about what kind of numbers could you have used? Well, could I have used 1 for x? Of course, because 66 times 1 will equal 66 times 1. Could I have used 2 for x? Well, yeah, absolutely. 66 times 2 will equal 66 times 2. So I could do this with an infinite amount of numbers. All right, we got a population model, and they're saying x is the number of years after 2005. And they're also saying that the population was 15,000 in 2005. Well, if that's true, how many years after 2005 was it when we were in the year 2005? 0 years. We have waited 0 years since 2005. So that means when x is equal to 0, that our y should come out to 15,000. Well, that's only going to happen in C and D, because if you plug in the 0 right here, these will just turn into 1, and then 1 times 15,000 is 15,000. So that's a fact that you should know. You should be able to narrow that down immediately. Like, this entire process should have only taken you like 4 seconds, narrowing it down to either C or D. But one last thing, we got to choose between C or D. So we have to figure out what's going on, whether it's going to be 1.04 or 0.96, but it's an increase by 4%. Now, if you're increasing something by 4%, that's relative to the 100% of that thing. So 100% plus 4% is 104%, which is 1.04, which means you're definitely going to use D. Just wanted to let everybody know that the way I'm teaching these problems, it's based upon a AI algorithm that I have invented myself in order to maximize what I expect somebody would want to know if they're watching this video. So some of these problems are taught at a very high level, as if I expect you to know a lot of stuff. Some of them are taught at a lower level where I don't expect you to know as much. If you are getting help with this particular problem, this is what you probably want to know. That's the AI algorithm that I invented because I am a genius. The function h is defined by h of x equals 4x plus 28. The graph of h of x has an x-intercept of a0 and a y-intercept of 0b. What is the value of a plus b? Well, this is what's known as a turn your brain off problem. You go to DESMOS and you click and click, because those are our x-intercepts and our y-intercepts. So what are we going to do? We're just going to take the x-intercept, which is -7, and add the y-intercept, which is 28, and then we're just going to go for a little vacation with all that free time we just got. All right, let's continue with the rest of this SAT. All right, we got to simplify this fraction, but easiest way to get this one done is to notice that x minus 7 can be factored out of the top, where if you take it out of the first thing, you'd have an 8x, and if you take it out of the second thing, you would need to put minus 3. So you can double check yourself. If you were to distribute this, it would actually get you back to where you started, because you would have this times that gets you that, and then this times that gets you that. So a little bit strange, but we're factoring out the x minus 7. And on the bottom, x minus 7 is actually going to be part of what you get when you factor out a 2 from here. So lucky us that the x minus 7 now cancels, and we're just left with B. All right, they want to know the area of circle B is a certain amount of times the area of circle A. So what we're going to do is try to set up the area of circle B. Well, it would be pi times the radius for B squared. But they're telling me that the radius for B is 129n. So I'm just going to pop that in where I see the radius for B, but I got to put parentheses around it, because otherwise I'm not squaring the radius, I'm just squaring the n. So I wouldn't want that. I want to put parentheses, so I'm squaring the entire thing. And then on the other side, some question mark times pi times 3n squared. And now we really just have to solve for question mark, because that's what they're asking for. They're asking how many times. Like literally you can put a time symbol right there. Okay, so how many is the question? Well, in order to solve this equation for question mark, we're going to cancel out the pi on both sides. And then you're going to get 129 squared times n squared equals question mark times 3 squared times n squared. And what's going to happen here is that the n squared just cancels, so we don't care about that. And we really just have to ask our robot what 129 squared divided by 3 squared is, and he comes back with an answer so reliable. I love that guy. They're saying we got a circle, it's got center O, and we got points R and S that are on the circle. Then they're talking about triangle ORS. So ORS, that's our triangle right there. And they're saying the measure of angle ROS, so that would be this one right here, that's 88 degrees. But then they're asking us about the measure of angle RSO, so that would be down here. I'm going to call that X. But here's the thing. We got ourselves a circle. And if we have a circle, then we can recognize that this one and this one are both radii. So that must mean that those two sides are equal. Well, if those two sides are equal, that means that these two angles across from them are equal. So if this one's X, then that means that this one's X as well. Okay, so now all we got to do is set up an equation, and we can actually just use DESMOS here real quick to say 88 plus 2x has to equal 180. And let's see, we zoom out and we get an answer of 46. So that's it. You can just use DESMOS to solve equations for you real easily. You don't have to think. And we're done with the problem. We got a business owner that plans to purchase the same model of chair for each of the 81 employees. His total budget is $14,000, which includes a 7% sales tax, which the following goes to the maximum possible price per chair before sales tax the business owner could pay based on this budget. So you could try to see if he actually could use the biggest number there, 184.94, by multiplying it by 1.07 first. Multiplying it by 1.07 takes care of the fact that there's a 7% sales tax. So basically take 100% and add 7%, and you actually end up having to pay 107% of whatever you're going to end up doing. So you can actually just do 1.07 times that. Okay, so we need to multiply by 1.07, but then he's got to do it for 81 employees. So did he go past his budget of 14,000, which was supposed to include the tax? Yes, he did. So now we could just go to the next one on the list, the next highest one on the list. And too high. So last one to type in. And looks like he just made it. So that one's totally fine. Now, if you want an alternate way of doing this, you could have just said, well, it's going to be x times 1.07 times 81 has to be less than or equal to 14,000. So what you could do is just take 14,000 and divide it by 1.07 times 81. And that would have gotten you the same answer right there. All right, so they said we have a right triangle with legs of 24 and 21. And they're saying that the hypotenuse can be written in the form 3 root d. Well, what does that mean? That means that 24 squared plus 21 squared will have to equal 3 root d squared. Now, we can actually just go to DESMOS to get the solution to this. If we use an x instead of a d, and then we just zoom out, and then we try clicking, but clicking doesn't always work. So then you zoom in, like DESMOS 101 solving equations, and you get 113. Now we can just confirm that 113 makes sense. It's not like 113 point whatever, because they said it's supposed to be an integer. So that's it. The value of d is 113. That's it. That's the end of the story. All right, we got to know how to write all of these as equations. They said that A is equal to 30% of B. So that's the same thing as saying 2.3B. And they also said that A is equal to 0.6C. And then they're saying C is equal to P% of B. Okay, and then what are they asking us for? They're asking us for the value of P. Well, I see P is right over here. So I want to start by solving for P in this equation. Now I can start that process by dividing both sides by B. And that would get me P%, but P% is the same thing as writing P over 100. So I now have that it's equal to C over B. Okay, well, one thing I can do is solve this equation for C, which would be A over 0.6, and solve this equation for B, which would be A over 2.3, and then I just get to plug those in. So right where I see C, I can replace it with A over 0.6, and where I see my B, I can replace that with A over 2.3. Okay, but that's all equal to P over 100. And now I can do keep change flip, where it's A over 0.6 times 2.3 over A. The A's cancel, and I just get 2.3 over 0.6. And that's the same thing as 23 over 6. So that equals P over 100, and we just got to figure out what P is. So it means I need to get rid of the 100 by multiplying both sides by 100. And now I get basically 100 times 24 over 6. That's a good approximation. So it's like 100 times 4, which means that we should be getting this answer. So it's a little less than 400, and that makes sense. I'm going to rewrite what they have by writing f of x equals, and then 201% is the same thing as 201 over 100. And when they say of x, well, that means you can just put times x, or just put the x right next to it. So 201 over 100 times x. So is this decreasing, or is it increasing? Is it linear, or is it exponential? Well, it is in the form of y equals mx plus b. So it's definitely linear. And is it increasing or decreasing? Well, that matters What matters is the slope. If the slope is positive, then you can guarantee that the thing will be increasing, and we're done with the problem. All right, check out this website and let's do this problem. It says the y-intercept of the line is k minus 5 comma b. Well, that's interesting because a y-intercept means that x must always equal 0. So that must mean that this k minus 5 equals 0. Well, that means that k must be 5. Okay, so now they're asking us to figure out what b is. But now that I know k is 5, I can put 5 here, and I can put 5 there, which makes this whole thing 12. So if I want to try to figure out the value of b, then I really just have to figure out how to work with the point 5, 13 and the point 12, negative 15 to figure out my b value. Activate super cheater mode. We're going to do a table. We're going to put the 5 with the 13, and we're going to put the 12 with the negative 15. And then we're going to ask DESMOS, how can I make an equation using y1 as a function of x1? Now, the way you do it is instead of putting an equal sign, you put a squiggle sign. So instead of putting y, you put y1. Instead of putting the equal sign, you put a squiggle sign. Then we want it to be in the form of mx plus b. So that's going to be m times x1 plus b. And look at that. It made the line that I wanted. But remember, all they were asking for was the y-intercept. And they were asking what's the value of b. B is the y-intercept. So that means that the answer is 33. And that's it. We're done. Go to this website or else. Keenan made 32 cups of vegetable broth. Keenan then filled X small jars and Y large jars with all vegetable broth he made. Whatever. We don't really need to read this because this is a particular problem type where they're saying that the equation blah 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 represents a situation, and they're asking what's the best interpretation of the 5y. Well, in that equation, we can focus on the 32 because that's the actual number that they gave me, and that's measured in cups. So the 32 is measured in cups. Well, what that means is that this must be measured in cups and this must be measured in cups. So basically, cups plus cups equals total cups. Okay, but they want to know the interpretation of 5y. Well, 5y must be measured in terms of cups. So I better see the word cups in my answer. Now, is it the total number of cups of vegetable broth in the large jars, or is it the small jars? Well, it has to deal with the y, and the y is for the large jars. So now I just read this, and I just double check that it makes sense. The total number of cups of vegetable broth in the large jars, plus maybe the amount in the small jars, that would get you the total cups of vegetable broth that he has. He's got some small, some large, and then he's got a total. So that's it. We looked for the word cups, we looked for the word large, and at that point, we could have just been on our way. All right, I'm going to show you how to use DESMOS for this one. You start off by just typing in the original equation, and then they said that we have no solution. So what we can do is just keep typing in each of those answer choices until we get parallel lines. That's not what we have here, so I'm going to move on to the next one. So again, you want to remember this parallel lines trick for guaranteeing that you have no solution. Now, you got to be a little careful. It does look like it's parallel here. They could have potentially thrown one that looks parallel but isn't exactly parallel. So technically, you kind of want to keep typing in the other answer choices just to be sure. But when you look at these are actually the same line. So that's not no solution, that's infinite solution. So that's not our answer. But then we do want to type in that last one right there just to confirm. If you're running low on time, then don't bother. Just instead go after the one that looks parallel and call it a day. But this one's definitely not parallel. So it was this guy right here. And now we're getting to move on. I recommend just plugging in each of these to check to see if there's a solution. So for the very first one, let's replace all of those x's with a's. And if I do that, I get a minus 29 equals 0 times a minus 29. 0 times anything is 0. So you get 0 equals a minus 29. So is the left side equal to the right side? That's what you're checking for when somebody asks you if something is a solution. You would need the left side to equal the right side. Well, if a was equal to 29, that would be true. But we're supposed to only be using a values that are greater than 30. So no, this one is actually out. What if I instead try to do this again, but this time instead of using x, I try using a plus 1. So everywhere I see the x, I put the a plus 1. Well, what's going to happen in that case? The a's are going to cancel right there. And you'll just get a 1 right there times a plus 1 minus 29 equals a plus 1 minus 29. Well, 1 times anything is always that thing. So I can actually just rewrite it as a plus 1 minus 29 equals a plus 1 minus 29. Is the left side equal to the right side? Absolutely, because it's the same thing. You could try to simplify this, but you really don't need to. Whatever way you look at it, no matter what simplifications you do, it's going to be that the left side equals the right side. So a plus 1 is looking pretty good. And they said that a had to be greater than 30. Okay, well, you could just pick a values that are greater than 30. So yeah, sure, we'll continue to keep this. And then we just have one last one where we just have to replace each of those x's with 29. Now, if I do that, what's going to happen on the left side is you get 0. What's going to happen on the right side is you also get 0. You get 0 times 29 minus a, which will be 0. So yes, you will get 0 equals 0, which means the left side will equal the right side, which means that it is a solution. So 2 and 3 is what we're looking for here. All right, we got a person here that has a fence, and the fence has a total area of W square feet. So I'm just going to say that the area here is W square feet. And it says, which equation represents the total amount of stain S in gallon? What are they talking about? In fact, over here, they said 1 gallon of stain will cover 170 square feet of a surface. Okay, is it kind of like a paint or something? I don't know. Anyway, it says, which equation represents the total amount of stain S in gallons needed to stain the fence in the yard twice? Okay, well, they said that if you use 1 gallon of this thing, it's going to cover 170 square feet. So I can actually do this by setting up a proportion that 1 gallon over 170 square feet is going to equal how many gallons? Well, S is the thing I'm trying to solve for. So S gallons, if I'm trying to do this fence 2 times over. So if I'm trying to do it 2 times, I don't want to just do W. I want to do W times 2. That's how many square feet. Okay, so I don't really care about these units anymore. So I can just erase them. I don't need them anymore. All I really care about is just 1 over 170 equals S over 2W. And now I want to get rid of the 2W that's being divided. So I multiply it on this side. And now I have 2W times 1 over 170, which is the same thing as 2W over 170. And I can reduce that by making this one 85 on the bottom. And now I'm done with the problem. As you may have noticed, the SAT Practice Test 9 doesn't have as many DESMOS problems. I think they're starting to adapt a little bit. They don't want people using decimals all the time, but thankfully on this problem, we can use it. We type in the equation, and they're talking about a horizontal line that would go through this at exactly 1 point. Well, that negative 79.75, that's really the key to the problem, because if we set up y equals that, then it will just go through that point at exactly 1 point. But now we just got to know which one of these is the same as that. So to me, just right off the bat, that one's going to be more than 100, so I'm not going with that one. That one's 100, clearly not that one. 9 over 2 is only 4.5, so it's got to be C. You can type it in to confirm, but no need. We are going to cheat our brains out on this problem. They are telling us it's a quadratic. They're saying that it's going to be modeling the depth below the surface of the water t minutes after a seal entered the water during a dive. And 6 minutes after it entered the water, it reached a maximum depth of 302.4. And then it reached the surface of the water 12 minutes after it entered the water. Based on the function, what was the estimated depth to the nearest meter of the seal 10 minutes after it entered the water. Okay, so let's get started with our super tricks here. Let's put down 6, 302.4. And let's look at where that is on the graph. Okay, it's up there, high in the sky, but we're really only dealing with up to 12 minutes. So I'm going to go to my window. Just help me look at this a little bit. And I'm going to change the max to 12 and the minimum to, let's say, 0. Okay, just zoom out a little bit. And now that's our point right there. But we also know another point. We know that 12 minutes after it entered the water, it hit 0 because it hit the surface. So in other words, it has no depth there. But remember, this is the maximum. So when you think about what this is going to look like, it's got to have symmetry going on around the maximum. So that means if it's hitting 6 to the right of the 6 at 12, that must mean it's also hitting over here 6 to the left of the 6 at 0. So that gets us an extra point, actually. And ultimately, we want to know what's happening at 10 minutes. So basically, we want to know the x coordinate at 10. Well, one way to do that is to get an equation that is going to contain these 3 points, 0, 0, 12, 0, and this point. Okay, now here comes the DESMOS magic. Are y'all ready for it? We need to start by making a table where we go 0, 0, 12, 0, and also 6, 302.4. Okay, now we're going to make one more line in DESMOS, and we're going to put y1 and then the squiggly symbol next to 1 on your keyboard. Do that instead of an equal sign. But then describe what a quadratic looks like. A quadratic always looks like ax1 squared, or ax squared, plus bx, or in this case bx1 plus c. So ax squared plus bx plus c is the form for a quadratic, but we're using x1 instead because that's what we were using in our table over here. Okay, so now that we've typed it in, notice how it made the quadratic for me. And now I can just go to DESMOS and type in x equals 10. It will make a vertical line there. That allows me to click. And now I've got the answer I was looking for. That at 10, I get to 168. And it said to the nearest meter, well, okay, it's already 168. It's not like there's any decimal there. So the answer here is just 168. So at 10, what was the depth? 168. This one just wants us to convert units. It's taking a rate of 250 square feet per hour, and it wants us to change it not to square feet, but to square meters, and not to per hour, but per minute. So what we're going to do is we're going to take care of trying to multiply this by the right fractions. The easiest one to understand first is that in 1 hour we have 60 minutes. We're going to multiply by that because it will cancel out the hour unit and leave us with the minute unit that we want. Okay, so that's good. We got to that unit so far, but we still need to get to this other unit of square meters instead of square feet. Okay, so what's the trick? Well, they actually are telling you that 1 meter is about 3.28 feet. So if I want to cancel out the feet, I kind of want to put that on the bottom, 3.28 feet. And I want to put the 1 meter up top. But is this going to do it? Well, no. In fact, what I still need to do is put another one of these. Or I could have squared it, whatever you like. But if I put another one, now feet times feet is feet squared, which means that that is going to cancel out with the feet squared right there. And meter times meter, that's meter squared. So at this point, I just have to write what's left. It's 250 times 1, which is 250. And on the bottom, it's 60 times 3.28 squared. So that's it. All I got to do is now just type that in, and I'll be on my way to the very last problem of this practice test. A sad day indeed. They're telling me that these two are perpendicular lines. And then they're saying which of the following pairs are also going to be perpendicular. So what I want to do is try to use the fact that perpendicular lines have negative reciprocal slopes. So if I solve this one for y, let's see, it would be negative 5x plus 1 divided by 7 divided by 7. Then that would allow me to get the slope here. So the slope here is negative 5 over 7. Now, if I solve the other one for y, that's a little trickier. You would do by equals negative ax plus 1, and then you divide by b, divide by b, divide by b, so that way you can get the slope here. Now, here's the thing. We know that they're supposed to be negative reciprocals. So what I really should have done after I got this slope was to take in the negative reciprocal of it. Now that would make it 7 over 5. So that must mean that negative a over b must equal 7 over 5. Okay, so I can say that positive a over b is equal to negative 7 over 5. And now I can check to see which one of these could also potentially be perpendicular. But I'm going to have to use what I just learned, that a over b is equal to negative 7 over 5. Okay, so let's go to this very first one. Let's solve this one for y. And we get 7y equals negative 10x plus 1. Divide everything by 7. And we find out that the slope here is negative 10 over 7. Now, if I take the negative reciprocal of that, that would get me 7 over 10. Okay, but if I solve this one for y, I would have negative 2by equals negative ax plus 1. I divide everything by negative 2b. And I find out that I can cancel out these negatives and that the slope is a over 2b. Okay, a over 2b. And I'm trying to find out if that is actually going to be able to equal 7 over 10. Well, what did we say about a over b on its own? We said that it's supposed to equal negative 7 over 5. So where I see this a over b, I can replace it with negative 7 over 5. Now I would still need to put like a 1 here so that way I can treat this as 1/2. And now is that coming out to 7/10? Well, no, this side is going to be negative, the right side is going to be positive. So that's not working. Now, are using the exact same equation for both B and C as they did for A. So that must mean I'm still going to want to try to get to 7/10 slope for this one. So that means I want to solve this one for y. I get by equals negative 2ax plus 1. I divide everything by b. And now I just want to make sure that this slope, this negative 2a over b, does come out to the 7/10, just like before. Well, we're once again going to replace the a over b with negative 7/5. Now when I multiply that by negative 2, will that come out to 7/10? No. If you put this one over 1, it will not. It will not do that for you. Okay, so that means it's not this one either. And we already got rid of this one. And I don't know why I skipped B. I don't know how that happened, but whatever. Let's go now take a look at B. So for this one, let's write it on the side over here. And we're just going to have to work on solving this one for y. So it's 2by equals negative ax plus 1. Divide everything by 2b, which really is all we need. Negative a over 2b. Will that equal the infamous 7/10 that we got from that first part? Well, let's do the same step that we've been doing over and over. A over b is the same thing as negative 7/5. And now we have the negative, and we also have the 2 on the bottom that's got to get multiplied by everything. So what do we really end up getting? 7/10. We did it. We finally got it to come out to the negative reciprocal of what the first equation had. So that means that we finally did complete this practice test. We did it, y'all.